All right, we guys get out your assignments if you haven't already. Okay. Okay. Maggie, you said number 42? It's, oh, yeah, it's odd. Yeah. Yes, it's odd! Because the sign on top is odd, everything else is even, and an even times an odd is an odd. What? No, that's not what I'm saying. I'm saying sine, the sine function is odd. Because if you think about the graph of the sine function, it's symmetric through the origin. Okay? Odd means it's like you take the graph and flip it over here and you get the same thing. No, an odd function. Okay, and then the rest of this stuff is all even. So an odd times an even is an odd. What's that? Because then you're going from negative pi over 2 to pi over 2, so you have the same amount below that's above, so it's going to be 0. Okay? So it's kind of, that's kind of a cheap shot. Because, I mean, you look at that and you go, what in the world, what substitution could I possibly make to solve that? And the answer is you can't. And that's why it's just from negative pi over 2 to pi over 2. Yeah, you just have to know. 38. 38. What does u equal? Just x squared. What's du? And then you need to change that into du over 2 dx, right? Huh? Oh, sorry. There's an x right there. That's bad of me. Okay, so then it becomes the integral from, if you plug 0 in here, you get 0. If you plug square root of pi into there, you get pi. So this is 1/2, and then this is cosine u. The derivative of x squared is 2x dx, so there is my x dx that I used to replace that x dx. Okay, Payson? Okay. Oh, can we finish 38 first? Okay, so now we have to do the antiderivative. So what's the antiderivative of cosine? Sine, just sine. You can, if you wanted to. You could go and make this 1/2 sine of x squared and then use the original numbers. Okay? But if you think about it, if you do that, the first thing you're going to do is you're going to take the square root of pi and plug it in there for x squared, which is just pi, so you're doing this step anyway. So it's just a question of when do you do it. Do you do it now or do you do it at the end? And it's a little bit easier to just do it in the beginning. Okay? Shaden? You put the what? What about it? Right, okay. So I've got to change all the variables into u's is the rule. Okay? So this thing right here, x squared, is u. So that's why this piece right there became cosine of u. Okay, but then I still have an x and a dx, and so that's why we have to do this derivative thing. So if I take the derivative of my u substitution, I get 2x dx, but I only want x dx, and so to get rid of this 2, I have to divide both sides by 2. So then this piece right here, the x dx becomes du over 2. Okay? Yeah. All right. Okay, Payson requested a quick question on number 40. What's your quick question on number 40? What is u? I think that's grammatically incorrect. I think you're supposed to say, what are you? In this case, I would let u equal pi t. Yep. So all the pi t's become u's. Does that make sense, Shaden? That as soon as you say u equals pi t, all the pi t's become u's. All right? So I've done this and I've done this, but I have to change that into a u also. All of the everything has to become u's. So that's why we take the derivative of this to get a dt. So the derivative of this is pi dt, right? But I only need a dt, I don't need a pi dt. So how do I change pi dt? Yeah, I divide by pi. So that means this is du over pi equals dt. So now I'm all set. I make the dt a du. Throw a 1 over pi in front so it balances. Oh, and then I have to change these things to pi over 6 and pi over 2. And let me be very clear, now that just means I can do the problem. I have not yet done the problem. Just changed it so that I can, yes. Because I take this 1/2 and plug it in there for, or this 1/6 and plug it in there for the t. Hi, Katie. And that gives me pi over 6. And then if I take this 1/2 and plug it in there for the t, that gives me pi over 2. Odd move there to put the books down and then walk around instead of just walking around and sitting down books all one step. Not sure. Okay, so the antiderivative of cosecant cotangent is? Okay, so this is going to be negative cosecant of u. I still have the 1 over pi in front. I'm not going to do a plus c because this has numbers. It's not indefinite integral, it's a definite integral. And then now I need to figure out what the cosecant of pi over 2 is and what the cosecant of pi over 6 is. So cosecant goes with who? Nope. Cosecant is 1 over sine. Okay? So what's the sine of pi over 2? Well, you guys all know that pi over 2 is 45 degrees, right? So sine of that would be 1 over the square root of 2. So if I want to do cosecant of that, it'd be square root of 2 over 1. So this is going to be square root of 2 minus, you guys all know that pi over 6 is 30 degrees. So the sine of 30 degrees would be 1 over 2. So the cosecant is 2 over 1. And that's how we're going to leave it.
Let me simplify that, see if I got the same answer.
Yeah. Because the derivative of cosecant is cosecant cotangent. Don't ask me why, it just is. I mean, we could figure it out using like the quotient rule and stuff, but when we did derivatives, that's one of the, oh, I get it, because like if I took her question literally, she'd be asking me if I have the ability. Ah, I see what you did there. That's clever. I got to remember that one. Can you I don't know. Will I? No, 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 no. No what is it? I don't know what. Oh yeah, I don't know. Can I? Okay. All right. I don't know. Can I? Yeah. The derivative of cosecant is cosecant cotangent. So that means the antiderivative of cosecant cotangent is cosecant. Did yours simplify to the same thing, Gage? No. That's a negatory. Okay. Anything else?
41.
Payson?
It's a tangent
Payson?
cube. What do you think it's tangent cube?
Easy for some, hard for others. Okay. Gage? Because tangent cubed is an odd function. And if you go from negative pi over 6 to pi over 6, there's going to be the same amount of the graph below the x-axis as there is above. So they're going to cancel out and give you 0. Correct. Why? They're so easy.
They're so easy. Why would you say that? Remember that this to this and it's odd. So why is the over cube not squared?
Because if you square a negative number, you get a positive number. But if you cube a negative number, you still get a negative number. So for it to be an odd function, when you plug a number in, it has to keep its sign. Like the easiest odd function in the world is just, well, the easiest one is x, but if we go x cubed, the reason why that's an odd function is because if I plug in x, I get x cubed. If I plug in negative x, I get negative x cubed. So I plug in the opposite thing and I get the opposite answer. Okay? An even function like x squared, if I plug in the opposite answer, I get the same answer. Okay? Okay. Yeah. This is called an odd function, and this is called an even function. Yeah, right. Yeah. Yes. So like if I plug pi over 6 in a tangent cubed, and if I plug negative pi over 6 in a tangent cubed, I get the same answer, but they're opposite, so they cancel each other out. Yeah. Uh-huh. Because you have to replace the dt also. You just what? So you let u equal t over 4, right? And then du equals 1/4 dt. And you're like, okay, this, I only need a dt. So if you didn't do that part, you wouldn't have the 4 in there and you'd get the answer wrong. In front. Okay? Got it. Anything else? 44. Right? Good. Awesome. Okay, but it's the sine of x. So 0. So this becomes u. So it's sine of u actually just du. Okay. Well, the cosine because you take the derivative of sine of x and you get cosine x dx. So this part becomes du, yeah. When you do the antiderivative, the du just goes away, but you still need it in there. Yeah, so sine of 0 is 0. Sine of pi over 2 is root 2 over 2. It's on your chart, yeah. I think your chart says 1 over the square root of 2, but those are the same thing. The antiderivative of sine is negative cosine. Nicely done. And so if you plug root 2 over 2 in there, you get cosine of root 2 over 2. Who knows what that is? Minus the cosine of 0 is 1. So it's going to be minus negative 1. So my answer is 1 minus cosine root 2 over 2. Yeah, root 2 over 2 is the same as 1 over the square root of 2. You just rationalize the denominator, multiply the top and the bottom by the square root of 2, and that's what you get. Sometimes some math teachers don't like that. There's an old school rule that you can't ever have a square root on the bottom. It's evolving though, and more that's okay, but for those that's not okay, you take and you multiply it by square root of 2 over square root of 2, which is just 1, so you're not changing the value of the thing. 1 times square root of 2 is square root of 2. Those two, square root of 4, which is square root of 2, so they're the same thing. So like 1 over root 3 is the same as root 3 over 3. Right. Yeah, this is the answer. Yes, that would also work. Yep. Okay, anything else? How many were there? Yeah, you said du over 2, so put the 1/2 in front. What do you get when you plug in 0? Yeah, but we have to change these things based on our U-substitution. If you plug in 0, you get 1. What do you get if you plug in 13? What is the antiderivative of u to the 2/3? Did you hear that? Because, thank you, Maggie, because that's on the bottom? Okay, but thank you for paying attention, unlike Katie, and being a contributing member of our learning community. I know, but I was doing it incorrectly, and since you were not paying attention, I was going to make a mistake, and there was going to be mass confusion in the class. But Maggie cares about the larger learning community, so she was paying attention, and she helped. For Maggie? Yeah, I'm going to take a dojo point from Katie and give it to Maggie.
I'm pretty sure I'm the only one who did it.
You play tons of sports, right?
Yeah.
Is that how you are on the basketball court? Whatever, I made my free throws. No? It's the same thing.
No, I'm not going to go around and help these people when they don't have.
Okay, so, Maddie, The antiderivative of this is you add 1 to the exponent, you get 1/3, right? So it would be over 1/3, which is the same as times 3. Right. Not what I was about to get. Yeah, okay, yeah. Yes. Everyone who retires is quitting, but everyone who quits is not necessarily retiring. Right. Well, when you retire, it's because you have reached a certain age where so that you're done. So you're saying, I am in a position where I no longer need a paycheck anymore, so I'm going to retire from my job and do whatever. Well, that depends on the job. So if you work at 7-Eleven your whole life and then you retire because you won the lottery, then whatever. For me as a teacher, I have to keep teaching until I have taught for 30 years and I'm at least 62 years old. And then when I retire, I get a certain amount of benefits every month for the rest of my life. Yeah. If I retire before then I don't get that. Yes, but I have to fill out paperwork. I can't just and walk out. I gotta, you know. So Mr. Olson is a great example. He told all of you guys he was retiring. That was, well, some students told me that he was retiring. That I felt was a little bit deceptive because he is still working. He just left here. Mr. Pugh said he got a request from him for a reference. He was going to be subbing somewhere north of here. I don't know, on the I-5 corridor, wherever he lives. Yeah, they were able to, patch things up. Mr. Olson sent Mr. Pugh a copy of the book that he published after he left here. So told him thanks. They had a really rocky relationship in the beginning, but they worked through it. When what? This happened before. You have a... Yeah, that's from this class. Oh yeah, I saw that this morning. Not very many people. Lexi was on there, yeah. I have not yet. I've corrected it. You did not get 100%, but you were a lot closer. So, yeah. So I'm sorry that I haven't put that in. I know that the grade that you have right now is devastating. It's not a B+. I don't know. I don't know. Elena, it's always either me or waiver. And you guys have all chickened out and you bailed out a waiver, so now it's, you did? All right. I'm not judging, I'm just saying, usually students in this class, you're either straight A students or you got a B in either a math class or a science class. That's the exact opposite. All right, number 1. So the first thing we did was we, yes? Nice. You should have gone in like Mason and sucked up and said, hey, I really like those shoes. Can I get an A? Totally worked. Yeah. Okay, first thing we did was we drew rectangles. So this says use the given graph of f to find the Riemann sub with 6 subintervals. I think we did this exact problem on the quiz. And so if I'm going to do left endpoints, that means my rectangles go from the left-hand side up to the graph. And then this one is going to go from the left side of that rectangle up to the graph. And then this one goes from that left-hand side up to the graph. And the left-hand side up to the graph. And then this one is going to go down the giraffe. Look at this giraffe. Yeah, I think it was this exact same problem. Okay, so this rectangle I would estimate is like 2.1. This is 3.6. This is 4, 2, -1, and -2.7. So, huh? I don't know, whatever. It's not, yeah, no, that level of accuracy is not necessary. So whatever those add up to be, that would be your estimate using left endpoints. And then if you want to make that into midpoints, now you need to take those rectangles and draw them up to the graph so that the middle of the rectangle is touching the graph. Okay, so then this one, if I want the middle touching the graph, it's about there. This one, I have to move it down. Does that make sense? Okay. So that was pretty easy. There you go. Okay. So then you would add all those up, right? Easy peasy lemon squeezy. It's going to be the easiest test you've ever taken. Okay, so then it says, let's do the same thing, but let's do it with an actual equation. All right? So my equation is x squared minus x, and I'm going from 0 to 2. I'm going to do 4 subintervals. So what is the width of each rectangle going to be? 1/2. And then to figure out the heights of the rectangles, hey, you need this. To figure out the heights of the rectangles, this says the right endpoints. So if I have from 0 to 2, what will be the numbers that are on the... Each one is 1/2. Yeah, so it's going to be 1/2, 1, 1.5, and then 2. So I'm going to put 1/2 in there, and then I'm going to put 1 in there, and then I'm going to put 1.5 in there, and I'm going to put 2 in there. No, you don't have to put 0 because it's asking for the right endpoints. And so these are the ones that are on the right. If it said left endpoints, I'd put in 0, 1/2, 1, and 1.5. Okay? If it said middle, that'd be gross. I'd put in 1/4, 3/4, 1 1/4, 1 3/4. Okay? So I'm not going to do all that because that math is fairly simple. Okay? Okay, and then you also can do this same thing using the fundamental theorem of calculus. So the antiderivative of x squared is... The antiderivative of x squared is x cubed over 3. The antiderivative of x is x squared over 2. That's the derivative of x. And then you plug in 2 and you plug in 0 and you subtract. Okay? So this is a Riemann sum. It's doing the rectangles. This is an actual integral. Okay? Oh, now you're paying attention because it's about you. Good? Okay. Oh, and then we did some area stuff. Okay? So if I wanted to interpret this in terms of areas, that means I'm going to make a graph of this. Desmos. We can't in this case because I don't know the antiderivative. Well, you could break it up into 2 integrals. Yeah, right. No, actually, you can't do that. We don't know how to do this. Nope, we don't know how to take that antiderivative. So yeah, Payson says plug in points. If I plug in 0, I would get what? Try again. 1. Okay. Let's plug in, I don't know, do you want to just plug in 1 because it's from 0 to 1? If you plug in 1, what do you get? 1. Okay, so what this turns out to be is, we talked about, it's not though, because if you plug in 1/2, what do you get if you plug in 1/2? 1/2 plus the square root of 3/4. What does that work out to be? Ugly. Okay, I probably wouldn't give you one like this, because this isn't a shape that we know. I was hoping it was going to be a semicircle on top of a rectangle. But that would be if this was like 1 plus square root of 1 minus. Yeah, so that graph would be, if we did go to Desmos, x plus square root of 1 minus x squared. Ooh, yeah, we don't know how to find the area of that. How would you find the area of that little shape? Huh. Yeah, it's yeah, so we wouldn't do one of those, okay? Oh, here's a super easy one. You got to love these. How do I express that as a definite integral from 0 to pi? Yeah, so you make that squiggly thing. 0 to pi, sine of x dx. Okay? Because we said 0 to pi. Because that's notation that they use for that. But that's why we change it into this. This is much faster. Okay? Oh, this is such an easy test. You guys are going to do so great on this. If the integral from 0 to 6 is 10, and the integral from 0 to 4 is 7, what is it from 4 to 6? It's got to be 3, yeah. Because these two pieces have to add up to the full piece. Okay? But do you understand why, smart guy? Do you understand why? No, not why you remember it. You understand why the answer is 3, instead of just remembering that it's 3. Shaden, you still need this. All right, not messing with that. Okay, then you guys remember, I'm sure, that the derivative and the integral are inverses of each other. So if you take the integral of the derivative or the derivative of the integral, those two things cancel out, and it's going to be, but this is a constant. Yeah. So sine of pi over 4, cosine pi over 6. Okay. And then if there's a variable here, this variable I know is on the bottom. What does that affect when the variable's on the bottom? Yep, Maggie's killing it today. Sine of x over 2, cosine of x over 3. Okay. Derivatives and derivatives and antiderivatives are inverses of each other. Okay, and then the rest of it is just taking antiderivatives, which we spent days and days and days going over, so I'm sure you'll be fine. Okay?